I'm gonna start off the video, and it starts off with just Amy and Mark. And Amy, let's see. So Mark is the owner of Country Oaks Composting, and Amy is a composting specialist. So they will be our tour guides through this virtual tour. And if you have any questions at any time, feel free to put them in the chat box. There should be plenty of time to get to questions. So, Amy and Mark, if you want to tell us a little bit about yourselves.
Sure. Yeah, my name is Mark Cherry. I own Country Oaks Landscape Supply. I got my start in the landscaping industry from my father. Ever since I was born, he owned various landscape supply companies, starting with L&C Stone Company on the east side in Mount Clemens. And in 1987, he started Country Oaks Landscape Supply in Clarkston, Michigan. And I worked for him at a very young age, cleaning bathrooms. And can you stop it there, Kelly? Thanks. And from there, we were mainly a hardscape company. We sold a lot of paving stone, a lot of bulk materials, mulches, soils, things like that. In 2000, after I graduated college in the 90s, I went to work for my father, managing his facility here in Clarkston. And I bought it in 2001 from him. Shortly, 2 years after that, I bought the store in Burton, the Atherton's store, which is now our processing facility. And basically muddled through the next 10 years through the bad economy. And in 2013, I saw my opportunity and I bought a tub grinder. We were already collecting wood waste, and we started processing the wood waste into mulch. And in 2016, we were getting yard waste collection. We were starting yard waste collection, and we thought we were making compost, but we learned after a week at the facility training management in North Carolina through the United States Composting Council that we weren't actually making compost. We were just letting material rot. So we quickly set up our yard to start with feedstocks and throughput to finished material. And we're continuously improving our operations, working on BMPs and PFRPs and process efficiency. And we're really proud of where we are today. I'm going to let Amy talk about herself now.
Hi there, everyone. You can hear me all right, can't you? Okay, good. I'm Amy Freeman, and I probably have, I've been around for a bit of time with composting and with the MRC. I started in the late 80s in composting, and then have been working with Country Oaks Landscape Supply and composting since April of 2017, I think. So for a bit of time, and I'm really glad to be working with Country Oaks because there's a real commitment to doing composting right. So I'm looking forward to this tour for you all. Wish we could all be in person. It's a gorgeous day today, so wish we could all be in person at the site, but this is the next best thing. So I think Kelly wanted us to mention a little bit of the artwork that we're standing in front of in your screen there right now, which is our hot box, which we're gonna tell you more about later as we move through. But this is mixing art with compost because compost is an art, recycling is an art, but we have this box that contains all of the controls for our negative aeration system, which we'll get into in just a little bit. But the cool thing about the artwork is that it incorporates art again into composting process, as well as a local artist that did the work. And then also the graphic itself is taken from several different well, the United States Composting Council's International Compost Awareness Week's poster is represented in there with the bees, and then a nod to agriculture with the fruits and vegetables over to the right side there, and then the pipes to the left that comprise part of our negative aeration system. So we're really proud of the work that they did on this this project, on the artwork. It was done in a graffiti style with spray cans, and it was actually a Fenton person too. So local it is. And as composting is a hyper-local industry, we're really proud to have this too. So Kelly, if you want to move on to the next, or Rollum Ferndock.
Yeah, so what we have here is back in our brush area. This is a truck dumping chips. This is actually more of our mulch area, but a lot of this material will make it into our compost after we screen the fines out. And this is what we see all day, every day. Many trucks filled with various things that are all sorted and put into the piles for processing. This is pretty, this is the backbone of our company here. This is, well, tub grinding. We have several of these machines that are designed to essentially reduce material. What we're doing here is actually not our feedstocks for our composting. This is actually primary grind for mulch. This is, we put big grates in and reduce it down as fast as we can through this machine. And we load it with 2 machines just to keep up with it. And it will go into a big pile when we're done. And that whole pile was ground up in January, February this year. We spent a couple of months grinding that up, and then we processed it again. It'll go into various materials like dyed mulches, hardwood mulches. It'll go, the fines will come out of it and go into our composting facility as a carbon source to all the grass clippings that we get. Here's our pouring the aeration pad for our negative and positive aeration facility. Basically, we have 8 air channels there. There are 2 8-inch poly pipes in there with holes through them, and that's where we stack up the windrows to put airflow through the piles. And that is that pad is approximately 120 feet by 90. It's pretty good size. We can get about 2,200 cubic yards of compost onto that facility. What we do first is we tub grind up the yard waste, and then it makes it onto that pad there, and there's the pad as charged with yard waste. And right now we're actively pulling air through the piles and back into the piles to do positive and negative aeration. Aeration is essentially where, instead of doing like what we did before, we're static windrows where we would just turn them with a windrow turner. We're applying air to the piles to speed up the composting process, have better controls, and to control odors, because the more air that you put into the compost piles, the less odors you have. When the piles go anaerobic, meaning a lack of oxygen, the microbes will release odors like hydrogen sulfide, ammonia, methane, and those odors can travel quite a ways, up to miles, which we experienced when, even though we tried to manage the piles really good, the wind would take it over our local neighborhoods, and we are in a compact area there. There are a lot of neighborhoods, so we had to change our process to aeration to limit odors, essentially. Do you have anything you'd like to add, Amy?
Yeah, our site is on a relatively small space. And as Mark said, with neighborhoods, we actually have neighborhood directly to the east of us. With the westerly prevailing winds, we have to be really cautious about causing odors. So the negative aeration has really allowed for us to be able to feel confident in reducing odors, and it's also allowed us to speed up the process in that first part while we're reaching thermophilic temperatures too. So it really has allowed us to increase production as well as be really good neighbors.
Okay, the next part of this video, because Mark was explaining in person, you're going to hear the computer audio. If there's a problem with the sound, please let me know in the chat box, but you should be able to hear the sound as he's speaking.
So, yeah, this is all computerized. Here we can some of the piles. We can see oxygen levels. In this case, this is the heat exchanger right here. So we can see the temperature of the air going into it and the air coming out of it. And this glycol line comes through here. It's pumped through this heat exchanger. And then the heat gets pumped, the hot glycol gets pumped through our floor and heats our building.
Cool.
From the compost hot vapor.
Cool.
So basically we have two units here. We have the left side, zones 1 through 4, and this is zones 5 through 8. So we have the left side here where we can monitor what's going on in those 4 piles. We can move air through the piles to the exhaust or through the piles into other piles to do positive and negative aeration. This is the right side here. We're at 152 degrees on row 7. Control the speed of the air traveling through. We're at 11% oxygen, so we're right where we need to be. And then we can look at trends of all the piles going back to when they're made. We can see the temps of all the piles where they're at and the oxygen levels.
Okay, you can stop there. What you see there is essentially our biofilter. So when we start pulling air through the fresh piles, they're anaerobic. The oxygen is depleted within those windrows within 7 minutes. So they're down to 0.1% oxygen levels, which is when the microbes will go anaerobic. So what we do is we take that air, that odorous air, and we pump it into this here, which is our essentially a mulch bed, and there are pipes that are underneath it, so that noxious air will get blown through there. And it scrubs the air, so it has almost a sweet smell, almost like a mulchy type smell to it. It really gets rid of the unpleasant odors. You can see, and in the mornings, there's quite a bit of heat going out of there, and it'll be steaming up a good 30, 40 feet into the air. So before we even put hot air back into the other piles for positive aeration, we will send the air to this biofilter for scrubbing, and then once the oxygen levels get up into the piles, we'll pump that into the other piles, because it's good to do a combination of both negative and positive, because if you continuously do negative aeration, the piles will kind of collapse and get compact. So if you can pump air into the piles, it helps the air travel through different, essentially, capillaries through the windrows. And it also, if the piles are cold, if we can pull from a hot pile and pump that into like essentially a new pile or a cold pile, like in the wintertime, we'll be pumping hot vapor into those new windrows to kickstart them essentially faster.
Do you want to talk about the heat capture part?
Oh, yes. I don't know if you caught it in there, but there is a heat capture unit in there. And that hot vapor, we can monitor the temps coming in. So right now I checked the temps of our piles, and we have some fresh windrows this morning, and they were up to 170, which is hotter than we like. So what we do in those cases is we increase airflow to cool them off, and we capture that heat in a heat exchanger, and the hot glycol that goes to that heat exchanger gets pumped through our floor for radiant heat, and it heats our building. And we're actually only using the power from zones 1 through 4. We have zones 5 through 8 that we don't have a heat exchanger on. but it will be utilized when we build our next building. Brian from AgriLab is going to come out and put another heat exchanger in our facility there in our hot box unit, and we'll be able to heat the next building, a 9,500 square foot building, with hot glycol. And to give you an idea how efficient it is, our 3,500 square foot building with both gas and heat usage in the month of April. Now, granted, we were shut down essentially because of COVID, but our heat, and we have LEDs and we're well insulated, was $120 to heat that 3,500 square foot building and electricity for the month of April. Good.
Yeah, that's really good. So we are really working on our impacts as a processing facility. So that allows us, that heat capture allows us to increase that capability of making a lesser impact too.
Here is I hired a gentleman who does graphics to come out and kind of show like essentially a cartoon version of how our system works. And it basically just shows a side view of the air being going in through negative into the hot box unit and then back out and for positive too. I think I did such a good job.
Mm-hmm. Kelly, if you want to hold it right there, just as we just moved to the windrows from the negative aeration system, and right there from those windrows on the pad, the material gets moved to windrows on site that are actually running north and south on that. But and then we are able to use the windrow turner, which you see on the screen right there, to aerate those piles. The aerial view will give you a much better picture of what our whole site looks like, but the windrow turner there, as many of you have seen a windrow turner that straddles the windrow of compost. So keep in mind that windrow has already gone through the beginning stages. It has reached thermophilic temperatures, 131 or 55 C for 3 days. And then it is moved over, actually it's staying on the pad longer than that, but then it's moved over and we're able to homogenize it with the windrow turner. And then Mark, I'll let you take it from there. If you want to add to that, I don't know.
Yeah, as Amy said, we like to we do a combination aeration and windrow turning. And the reason I like to use the windrow turner is technically we meet PFRPs on the aeration pad. Basically in the US, over 3 days at 131.5 degrees temperature is what they recommend for meeting the process to further reduce pathogens and weed seeds. But I like to make sure we hit every part of the compost. So we put it in the windrows and we'll turn it with that machine to make and take temps to make sure that we're above the thermophilic 131.5 temps. And the flails on that machine reduce the material more So when we put it in our screeners, we get better production. We get more fines out of it because the windrow turner will reduce it more. So we turn it twice after it comes off the aeration pad, and then we set it over for curing for 2 to 3 months, and then we'll screen it and move it over to the finished pile. PFRPs is the process to further reduce pathogens. So when we get that heat to all parts of the compost, we will kill things like E. coli, salmonella, whatever can make it into those piles will be killed, and it will kill all the weed seeds essentially. That's what process to further reduce pathogens is. You're welcome. You can see that if you stop it there, if you see that windmill in the background, my neighbor is, yes, that one, right? Can you see that? They get two of them to go in there. That windmill, my neighbor is pretty handy and we get along really good. And he went out to Connecticut and somebody let him have that windmill. He wanted to put it up on the property. Right next to there is a pond. And he built that windmill and I paid for it. I had the easy part. But there's a pump up there that pumps oxygen into aerates our pond there. So all the fish and frogs are happy. And I thought it was a cool theme with what we're trying to do at our facility with lessening our carbon footprint. Instead of hooking up an electrical aeration unit, I like the concept of putting an aeration unit into the pond. Okay, you can go ahead. Those piles are still pretty active. You can see it was warm that day and there's still a lot of steam and heat coming out of those piles. They're still very active. And in the background there, you can see the building that we heat with the hot vapor coming out of the static piles. Yes. Here's one of our screening units. This is our Edge 622. And this one has 1/2-inch screens on it. And we have hydraulic fans to suck out plastics out the discharge end. And on the other end, we have fans to get as much plastics as we can out of these piles. And we essentially had to build a moat around this thing, or berms around this thing to help catch plastics so we can kind of control them, because there are just so many plastics that come in on the yard waste. Right now, we're actually running 2 screeners to get through our material because we're trying to make space for our new building that's coming up in the next few months. Do you have anything you'd like to add?
What's the moisture content of what's being screened there? Of course, with any screening process, the drier the material, the easier it is to screen. So we run those screeners. We're really dependent on weather conditions too when we're screening, because we are hopeful that it's not going to be too wet as well.
Can you pause it there?
Yeah. Okay.
Go ahead.
Yeah, we're hopeful that it's not too wet, because as with any screening process, it clogs up the screener. So we really want to do screening at optimum times, and it makes that process a whole lot easier. And then you will note, you can see the There's a dumpster to the right. Yeah, yes, Kelly's circling it there. That dumpster there, that roll-off dumpster, is to capture, you can see a hose coming off there too. Yep, right there. That is capturing some of the contaminants. We're trying to capture all of the contaminants, but plastic is a real issue. It's very, very real for composters. Film plastic, as well as water bottles or just various plastics into the composting process. When you're processing municipal yard waste, it's really difficult when you've got so many contaminants in it that are coming into us. So we have blowers on, we have a blower on there that is siphoning off. We have a suction that is siphoning off some of those plastics in that hose there. And then we also have a blower. Is that, can you see the blower on there, Mark?
Yeah, that's right. We have a blower right
Blower
here.
up at the top there to capture some of the contaminants, namely plastics.
It blows
that are in
here,
there.
and then we have suction over here to try to grab whatever we can and bring it down to essentially a track back to pull out plastic, this finer plastics.
And plastic, again, is a real issue for composters. Contaminants of all kinds, but especially plastics. Film plastics, plastic bags are a real pain. I did attend last week's conference of all of the Canadian Composting Council's conference as well. And one of the speakers there was from Ohio State University, and he talked about the health issues when you have plastics in the environment of food production, and it's a real issue. So anything that MRC can get out there, anything that Eagle can get out there, reducing contaminants is a real issue for composters. So I just wanted you to, I wanted to point out the ways that we are trying to capture as much contamination as we can and get it out of the system. Okay.
From Isabella Garamone, I believe it said basically where our feedstocks come from. All of our feedstocks at this point come from yard waste. Municipal waste haulers, they will dump, landscape contractors will dump at our facility. It's mainly composed of yard clippings, leaves, a lot of grass clippings, trees will be in there. And we'll mix it according, we try to get a mix of about 30 parts carbon to 1 part nitrogen. So we'll mix fresh stuff to old stuff and do all kinds of things to put the optimal mix onto the aeration pad. Does that answer your question?
I believe she's also asking if you guys compost food waste, residential food waste or food scraps, and compostable plastics and cutlery cups.
Well, we certainly can. We are actively trying to find food waste sources, but it's difficult in the state because, well, one, I'd have to invest in a collection truck of some sort to get the food waste, and I'd have to go to local restaurants or grocery stores. But essentially, I'm competing with the landfills, and it's going to be more expensive to collect food waste than it is for landfills, and it's not very popular with the restaurants and the grocery stores to pay more to get rid of their waste. So that's a bit of a challenge, and it's how much do I want to invest in, collection trucks, the ones that pick up the totes, to dump and to handle food waste. So basically what comes with the landfill and food waste collection, the price has got to get more centered for us to get more of, or get that material. But
And
I'd
yeah, and
love
Mark,
to
if
have
I can ask you another part of a question that was already asked. You are a you work with landscapers, and so you collect a lot of that kind of landscaper yard material, and that's why you get a lot of yard clippings, is that correct?
Well, no, most of it comes from municipal waste haulers,
Okay,
from garbage trucks essentially. But we do have a lot of landscape contractors that we do business with who do, like when they do yard cleanups, like say they vacuum a lawn in the fall, we'll get that type of material, and we get a lot in the fall. And we also get if they collect their grass clippings, we'll get those too.
And we also, we have contracts with municipal haulers for yard waste collection at the curb. So those that have contracted with waste haulers for their yard waste, we manage tree waste from large scale projects, like for instance, the pipeline project that's going through Genesee, Oakland County, Saginaw, Genesee, Oakland County. We process a lot of that wood waste from there. That comes to us, as well as landscape waste. We do manures as well. But again, food waste, talking about food residuals, that's where, again, the processors are really hoping that we can move it forward in Michigan with organics, looking at the whole picture of organics. We are equipped to be able to handle food waste on a large scale now, and we've set ourselves up with the negative aeration to be really efficient with that. But infrastructure, and that is something that the Michigan Organics Council is working on as well, is the infrastructure for being able to, like Mark referred to, transport of that material is really challenging for operators, because you know there's food waste being generated in many places, but it's hard to get it from point A to point B because of hauling. So that's something that is very much needed in infrastructure. So we're looking to MRC, MOC, which is Michigan Organics Coalition, and the United States Composting Council, and EGLE, all those who can move organics diversion forward and increase that in Michigan. So just wanted to add that. But on a very small scale, we have accepted some food residuals as well as compostable serviceware on a very small level. But I did notify our licensing operators, Aaron at EGLE, and we are on to be able to accept food residuals. So we're ready, bring them on.
Does that answer your question, Karen?
yes, it does. Thanks, Mark.
Okay, yeah. If you go back before this, you'll see us loading one of our trucks. We have several trucks that we use to haul finished product around, and there it is right there. Yep. So we'll do various blends, or just send the truck out as is with compost, and that'll go to our customers or to our yard and Dixie Highway, and we'll load it with those trucks. Okay, go ahead.
And to the part where Mark has compost in his hand there, like right there, that material will go out to various markets, not only the landscape market, but we are really moving into the agriculture market as well, which is a great opportunity. And then going back to the Michigan Organics Council, the market development is really critical to compost operators as well, because this material is very important to many different sectors, not only landscape, but agriculture, and I could go off on a whole tangent about agriculture too, and how important as far as climate change, getting carbons back into the soil, such importance. So we are proud to be part of that, of this industry, and being able to make a difference in that.
All right, basically what's happening there is we got filled up on brush in the back, so we had to make some more space. And we're engineering that back area there for more brush collection. That's one of the ponds we use for mulch dye and adding to our mulches. It's actually a pretty piece of property. It's 28 acres and there's all kinds of wildlife back there. Deer, just it's nice.
This may be a good time, Mark, to talk about what you guys do with that standing water and how you manage water on your site.
Water travels from the west of our property to the east, and it eventually makes its way down to Thread Creek. So we have various ponds on the property, which in the wet times will overflow and travel down streams to a pile that's on the east with essentially an overflow valve on it. We use a lot of the water that we collect from rain for compost. So when we do grinding, we will add 60, 70 gallons of water a minute to our compost because it dries out so fast on the aeration pad. And for mulch production, we use a lot of that collected water for mulch dye, which is about 30, 35 gallons a minute for that. And we'll add it to other various mulches to because they'll be so dry. We're always using that collected water for those processes. Yeah, it's basically a series of ponds that all end up into one area and overflow towards Thread Creek.
And then just to add to that too, our site was completely engineered in the beginning, well, as you began the process of adding considering the aeration pad, completely engineered so that with the proper slopes and for water issues as well. So it was completely set up to be a compost operation.
Yes, I hired Brian, who is Jaros from AgriLab, who developed that composting facility. Real smart guy to come out and engineer the property for what we do, and it was very helpful. It was worth every penny. So you can see we're getting tight there. He's struggling backing up, trying to make his way around some of the piles we have in the back. That one pile on the left is enormous. It's probably about 2 acres of primary grind. Oh, and I saw somebody left a message on there regarding PFAS. For the type of material that we use and where it comes from, we don't really have an issue with PFAS. If we started getting into more compostables, it might become an issue as far as compostable foodware, plates, silverware, that type of thing. But it's really, I took a class down at USCC in the wintertime regarding PFAS, and it's the amount that gets into our facility would be so minimal. It's like, I don't know how many parts per billion, but it's very, very minute amounts. Oh, sorry. Thanks, Rick. Paper products. Okay. Yeah, we really don't have paper. It's all wood.
Yeah, there's the aeration.
Yep, there's the aeration pad. That's our bagging unit. We bag up soils and mulches into that unit there. And it has a attachment, if we so choose, we can fill tubes with compost for sediment control or garden socks, those types of things. Not really a market for that kind of item, but maybe there will be someday.
And then Kelly, were you able to add some of the drone footage into that so that we can see the overview of it? And if not, that's okay. Maybe folks could be directed to our website too, because we do have some great drone footage of our site so that you can actually see over the top. I mean, I know that there was some drone footage of the grinder, the tub grinder there, but like we had it fly over our whole site, and it was very cool. So if anybody wants to see more of that, I would suggest going to our website. But the last thing that I wanted to say to be focused on is this morning in the opening session and Matt Flechter's address to us, in his opening remarks, he mentioned Eagle's focus on health and safety and the welfare of the work that we do as recyclers in Michigan. And again, composting is organics recycling. So we are a part of this, a big part of this actually. But I'd like to add that that with our compost site here, that we add quality into that in the products that we make, because the compost operators are really a full circle kind of thing. We are the collection, the collection, the processing, and the utilization of this material as well. So we have control from the minute that we take it in until the minute it goes out. We are the actual processor as well. And at Country Oaks, we are part of the Seal of Testing Assurance Program with the United States Composting Council and the Compost Council Research Education Foundation. And they set the parameters for the STA program. We are a participant in that, and there are 4 of us in Michigan that are, but quality along with the health, safety, and welfare of this industry and the work that we all do, we're proud to do that. We're proud to be part of that, to do the best management practices, as well as process. We take very seriously the process to further reduce pathogens, which is the PFRPs. So we work really hard at that. And I just wanted to tie that in with Matt's talk this morning, and that he wanted to connect recycling. And I'd like to connect recycling, especially organics recycling, with climate and equity connection as well. So that's all I have to say. And it does look like we've got lots of questions up there, and I'll turn it over to Mark or whoever's.
Amy, before you do that, will you please say your website, please?
Our website is www.countryoaks.com.
It's countryoakslandscapesupply.com.
Sorry.
Thank you. That's great. And Mark, I'll just read some questions off here for you. Rick is really asking about compost socks, and you talked about this when we talked last week. Help us understand what compost socks do and why you think they're a great benefit for new construction, in silt retention, and all that stuff.
Well, basically they're designed to compete with silt fence, which is basically what's used in our state. We're addicted to silt fence in this state, where other states have moved beyond silt fence as a form of sediment and pollution control to keep our waterways clean. So it's proven that compost socks collects more sediment and pollution runoff, and are more sightly and easier to install than silt fence. So I think there might be an opportunity for that in the future with compost socks to perhaps even replace silt fence in this state. But there's going to be a lot of education and a change of philosophy here in Michigan. I think it'd be a good thing for our waterways to switch to compost sock.
That's great. You know, maybe we can ask Rick Lombardo to unmute himself at this point and just a little bit about PFAS, because there have been some questions about PFAS and what the sources of PFAS are. Rick, can you unmute yourself and answer these questions for us?
Sure. Hi, Karen. Great job, Mark and Amy. That was a great presentation.
Thanks, Rick.
Thank you. So I will first clarify, I am not considered an expert in PFAS. However, I do have access to people that might be able to help provide more insight. But from what I understand, so PFAS is added to paper during the emulsification process, during the pulping process. And it's typically added in the food service packaging setting as a degreaser. And what happens is when you have streams that are coming from municipal streams, like similar what happened in Ann Arbor earlier this year, you run the risk of maybe having some non-BPI certified or CMA certified or equivalent entering those streams. And as a result, we run the risk of accepting non-coated or polyethylene coated paper products that will have high levels of PFAS in addition to non-compostable coatings and laminates. But as it relates to the PFAS, the BPI and the CMA, which is the Composter Manufacturing Alliance, they basically will not certify products with added PFAS. So if you have a paper plate, cup, bowl, what have you, you have to show that you have no PFAS in that chemistry. But traditional, let's say you were to go to Kroger, Meijer, Costco, what have you, and buy one of those cheap white paper plates that have a very thin coating of polyethylene, which is not compostable, the paper itself would be filled with PFAS. And when you accept municipal streams, that could be a potential challenge if you're trying to keep those products out. So that's pretty much it, Karen, from what I know. But I would love, if anyone does have questions, I would be more than happy to do what I can to answer them, but also I would be more than happy to connect people with people that maybe know a lot more about this subject than I do.
That's great. Thank you, Rick. We are reaching the end of our program here today. Mark, is there anything, any last words you have for the audience?
Well, I'd just like to thank everybody for their interest in our company, and I appreciate everybody taking their time out of their busy schedules to see our humble facility. Anything from you, Amy?
I don't think I have anything else, but I'm really glad that we got to see it this way. Hopefully another time we'll be able to do it in person where you can really be on site and see it and smell it and touch it. Thank you, everyone.
That sounds great. Thank you. Thank you both, Mark and Amy. Appreciate the tour. Thanks for Kelly Shelter to take the video and put all that together. It was a big job. I do want to remind you that we have the Next Cycle Michigan session tomorrow. That's a really interesting session. If you haven't learned about Next Cycle yet, it is time. There is an organics track in that innovation challenge that I think would be of interest to anybody involved in organics management and in trying to break through with some big ideas and some innovations in this area, like the use of compost socks more pervasively across the state. So it is time to think about these ideas and start to form teams of people that can put that together. But before we leave, again, many thanks to our sponsors and our exhibitors. Many thanks to my staff, Kelly Shelter, Help Desk Terry Ratterink, and Katie Fournier on the back end, helping with everything. And thank you best and most of all to all of you who makes this possible. It's the sharing of all this information that we do amongst ourselves that allows it to grow and bloom. So you'll receive another email tomorrow morning from us that has links for tomorrow, but it's the same email that you'll probably see today. So you should have all the links you need for tomorrow. And I hope you join us for each and every session that we have. It's going to be good. Thank you all for being here with us today, and we'll talk soon.
Thank you.
Bye, thanks.
Bye.
Bye.
Bye-bye.